Good evening, all of you. Today we are going to see about frequency measurement with Lissajous figures. So, to measure the frequency, unknown frequency, we use a CRO, cathode ray oscilloscope. So, this is the screen. So, inside a CRO, the main component is the CRT, cathode ray tube. Okay, this is CRT, cathode ray tube. So this cathode ray tube has vertical deflection plates and horizontal deflection plates. Generally, horizontal deflection plates is given a sawtooth waveform. Vertical deflection plates, we will be giving the unknown signal as the input, and we can see the pattern in the screen. This is how a CRO is being used. So it has horizontal deflection plates and vertical deflection plates. Here you will be having cathode, filament to heat the cathode, control grade, screen grade, accelerating grade. Then you have two horizontal deflection plates. That means it will deflect the electron beam horizontally. Similarly, you have vertical deflection plates. This will deflect the electron beam vertically. If both the signals are absent, then the electron beam will strike the center of the screen. So this is the idea. Generally, we will be using sawtooth waveform for the horizontal deflection plates. Okay. But to measure the unknown frequency, what we do is the known frequency is given to the horizontal deflection plates. I already told you what is horizontal deflection plates. Okay. Then the unknown frequency is given to the vertical deflection plates. If these two frequencies are given, you can see some pattern on the screen. Some are regular pattern if the frequencies are multiples. Otherwise, you can see, but it will be random motion like patterns. So we are not comfortable enough to record those values. So this is the basic idea. So first we will see some of the patterns, how to measure. So generally what happens is we have to give the unknown frequency is to the vertical, and here we know the known frequency. Keeping this in mind, how to measure the frequency. For example, if you see a circle, in the screen if you see a circle, this point is 1 and this point is 1. Here vertical frequency is equal to horizontal frequency. That is, the unknown frequency is equal to known frequency. Suppose the known frequency is 10 kilohertz. If you see a circular pattern, that means unknown frequency is also 10 kilohertz. That's the meaning. Okay. Now we will see another case. Suppose you are seeing a loop like this. So here this is one tangential point 1, this is another 2. Here it is 1. Here the vertical frequency is equal to twice the horizontal frequency, FH. That is, if this is 10 kilohertz, Then the vertical frequency, that means the unknown frequency is 10 into 2, that is vertical frequency is 20 kilohertz. So one thing you have to keep in mind, this frequency is known. So here you can say this is basically a signal generator, sinusoidal. So here we are giving single tone frequency. If I say single tone frequency, it is sinusoidal, only one frequency. So here you are choosing a sine wave and you are setting some frequency, say 10 kilohertz, and it can be varied, variable uh, sine frequency can be varied, and even the intensity of the signal, amplitude also can be varied. So it's basically a function generator. You will be having sinusoidal waveform, triangular waveform, square waveform, like that. If you use triangular square wave like that, then it will have harmonics. Okay, that means a triangular waveform or square waveform will have a sinusoidal with different frequencies and different amplitudes combined together to give that waveform. So generally we cannot use signal wave other than sine wave, because sine wave or cosine wave is single tone frequency, one fundamental frequency, that's all. But all others will have n number of frequencies. So this measurement is used to measure only for sinusoidal waveforms or cosine waveforms, both are same only. It is shifted by 90 degrees. Of course you can go carry out phase measurement also. So the first criteria what you have to remember is the input given to the CRO is sine wave. The known frequency is also sine wave. Both are sine waves. That's the idea. So if this kind of pattern, if you see, you have two tangent points. So 1, 2. So vertical frequency is equal to twice the horizontal frequency. I told you an example. If it is going to be 10 kilohertz, then the vertical frequency, unknown frequency is 20 kilohertz. Okay. The next waveform will be, now you have 3 loops. Instead of 2, you are having 3 loops. Like this. So here you have 3 and here this side you will be having 1. So here vertical frequency is 3 times horizontal frequency. That means if this is 10 kilohertz, this unknown frequency is 3 into 10, which is 30 kilohertz. Similarly you can have 4, 5 like that. You can have 4, 5 like that. Now one thing you have to remember is, if you want to see a regular pattern, then the unknown frequency should be multiples of the known frequency. Then you can see a clear loops. But if it is a fractional frequency like that, then you won't see a clear pattern. Okay. Right. Next we can have patterns like this also. That is, so first you are having like this. So here it is 1. The tangential here it is 1, here it is 2. So in this case vertical frequency is equal to 1 by 2 horizontal frequency. That means horizontal frequency is 10 kilohertz, 10 by 2 vertical frequency is 5 kilohertz. That means the unknown frequency given to the CRO is 5 kilohertz. Next, instead of 2 vertical loops, you can have 3. This tangential point is only 1, but here you have 3. So in this case, vertical frequency is 1 by 3 horizontal frequency. That means if this is going to be 10 kilohertz, so for to make it simplified, I make it 12 kilohertz, because I don't want fractional values. So I adjust the function generator in which I have selected sinusoidal output. So you set to 12 kilohertz. In this case, 12 by 3. So this will give you 4 kilohertz. So if you are not getting a regular pattern, then what you can do is you can adjust the known frequency so that you get a clear pattern. That is in our hands. Okay. Next, if you have a 4 loop like this, say I am having 4 vertical loops. In this case, vertical frequency is equal to 1 by 4 horizontal frequency. So now the known frequency is 12 kilohertz. So in this case, what will happen? 12 by 4, 12 kilohertz by 4. So you will be getting 3 kilohertz. So the unknown frequency is 3 kilohertz. So that's all about this important topic on how to measure frequency using Lissajous pattern. I have shown you analog CRO. You can do the same thing with digital CRO also. In that you have multiple functions so that you can store, evaluate. So that kind of options is there in storage oscilloscope, storage digital oscilloscope. So now I have shown you only analog oscilloscope. So you switch on the. So another important point is unknown frequency is given to the vertical deflection plates, and known frequency is given to the horizontal deflection plates. This I have told you. But another important thing is you must know the acceptable voltage level of the particular CRO. For that you have to look into the manual of the company's manual of that CRO and see that what is the acceptable input at the vertical deflection plates as well as the vertical input as well as the horizontal input. Suppose if they specify you can give a maximum of 5 volts, maximum of 10 volts, maximum acceptable voltage of 30 volts. So you should not go beyond that amplitude level of the input frequency as well as this frequency. So in the lab, this side you will be having a function generator in which you can select what? Sinusoidal function. You will be having other functions also. You select sinusoidal function. Here also you select another signal generator. You select sinusoidal function. First you try, say this is 10 kilohertz, this is also 10 kilohertz. Okay, then you must see a circular pattern. Okay, then you adjust this known frequency and unknown frequency so that you see a regular pattern like this and measure those values, from which using the known frequency you can always calculate the unknown frequency and verify theoretical and practical values may slightly differ because so many errors can happen due to the equipment itself. So you fine tune and see the readings and check whether the unknown frequency, whatever answer you get for this case, say you should get 3 kilohertz. Yes, it's 3 kilohertz is showing in the signal function generator in the sinusoidal mode. That's all about actually the function generator, the output will be very small. That is not going to affect your CRO, that is there. But as a general precaution, why I am telling this, because when you work with some power lines like that, you cannot supply that say 230 lines 50 volt. That 230 lines 50 hertz cannot be supplied directly into the CRO. Then the whole system will get damaged. So there will be an upper voltage limit for a particular equipment that you must go through the manual and then only you have to connect to the system. So if at all, if the voltage is going to be a very high, say 230 or 100, you step it down using a step down transformer and see that it comes down to 5 volts, because you are worried about only about the frequency, not about the amplitude. So you step down and make it 5 volts and then give to the system. Thereby you can measure the unknown frequency of the real time applications. When it comes to laboratory, you are using a well known function generators which has sinusoidal output with varying frequency range. These are the some of the important points I want to tell you regarding how to work with Lissajous patterns using CRO in the laboratory. As well, you can use the same technique while you are applying in the field work. So in the field work, we must be very cautious. What is the voltage you are expecting, and it should be the signal output should be acceptable to the equipment. Here in this case, it is analog cathode ray oscilloscope. That's all about the measurement of unknown frequency using Lissajous pattern using analog CRO as well as digital CRO. Thanks for watching this video. Nandri.